IC types based on packaging. ICs are divided into different categories based on the different packages applied to them. These packages protect the ICs and connect them to the board or system. Some common packages for ICs are DIP packaging, dual inline package. This type of packaging has two rows of bases located on both sides of the IC. This package is one of the oldest and most famous IC packages. SMD packaging, surface mount device. In this type of packaging, IC bases are connected to the board surface and the IC is placed directly on the board surface. SMD packages are usually smaller in size and are widely used in the electronics industry. QFP packaging, quad flat package. In this type of packaging, IC bases are connected to the four sides of the IC in a square or rectangular form. These packages replace DIP packages and are used for complex ICs with more pins. FPGA packaging, ball grid array. In this type of packaging, IC bases are placed under the IC in the form of small balls and connected to the board in a grid. These packages are used as a suitable alternative for ICs with high capabilities and more heat. FPGA packaging, pin grid array. This packaging is similar to FPGA, except that the pins are placed under the IC and connected to the surface of the board or socket. There are also other packages that are designed for specific needs and specific applications. Choosing the right package is based on the required system and the electronic components used. IC pin numbering. The pin numbering of ICs is based on common standards and symbols used to designate the function of each pin. In this numbering, each pin has a brief coordinate as a representative of the function of that pin in the IC. For example, in a DIP, dual inline package that has pins on two sides, the pins are numbered from one side to the opposite side. Conventional numbering starts at base 1 and increases from right to left. Also, SMD, surface mount device, packages also have abbreviated pin numbering. In these packages, the pins are placed in an array and under the IC. In every datasheet that contains technical information about an IC, there are diagrams and tables that show the pin numbering. These datasheets include information such as the name of the function of each pin, types of input and output signals, electrical specifications, etc. What is meant by IC generations? ICs have different compression of internal parts, which are named in different categories based on this number of internal parts. SSI consists of 1 to 10 transistors and 1 to 12 logic gates. MSI includes 10 to 500 transistors and 13 to 99 logic gates. An LSI consists of 500 to 20,000 transistors and 100 to 9,999 logic gates. VLSI consists of 20,000 to 1 million transistors and 10,000 to 99,999 logic gates. ULSI more than 1 million transistors and 1 million logic gates. IC types based on usage. ICs, integrated circuits. are divided into different categories based on different uses. We mentioned some types of IC based on their use. Network ICs, used to connect devices and transfer data. These ICs include Ethernet ICs, Wi-Fi and Bluetooth ICs. Audio ICs, used to process audio signals and amplify sound. These ICs include sound amplifier ICs, audio codec ICs, and audio effect ICs. Video ICs, used to process video and image signals. These ICs include image decoder ICs, image encoder ICs, and image processing ICs. Automotive ICs, used to control and manage electronic components in cars. These ICs include engine control ICs, safety system ICs, and vehicle navigation system ICs. Medical ICs, they are used in medical equipment and medical devices. These ICs include medical care ICs, monitoring ICs, and medical equipment ICs. Consumer ICs, used in daily consumer devices and equipment such as televisions, radios, washing machines, etc. Energy ICs, used to manage and control energy consumption in electrical and electronic equipment. These ICs include power supply management ICs and voltage regulation ICs. Note that each of these categories includes different subsets of ICs, each of which has its own functions and applications. Also, with the advancement of technology and different needs, new and more advanced ICs are introduced to the market.
This video is part of a wide range of electronic content about ICs. Learn from 0 to 100 of this field. Refer to the Comprehensive Electronics Training of Danesh kit on my YouTube channel.